Hey, are you wondering if there's any open source models that are really good at tool calling and agent orchestration? Because there's always been this gap in the market that we can't really get open source models all the way there. They're always about that 85% accuracy rate. If so, I've got some good news for you. There's actually a new model on the market called Kimi 2.5, and it actually excels at exactly that, both on agent orchestration and tool calling. And it does it in parallel. And in this video, we're going to jump into what is Kimi 2.5, how you can use it in open code, and some other things that you should probably just look into. What is the new Kimi model that came out? So looking at the K2.5 model from Kimi, we can see it's actually just a new multi-model, and it actually has visual capabilities now. And this has allowed it to do a lot more complex tasks. And the one neat feature with it is this idea of agent swarms and doing up to 1,500 tool calls at once. I haven't tested it, the 1,500 tool calls, very cool idea. But one thing I am seeing really well is in terms of performance benchmarks. So they got their one on screen here. All right, if we just jump to their benchmarks here, we can actually see in terms of their agents, in terms of how they're scoring themselves, they're doing quite a lot higher than GPT 5.2 high and even Opus over here. So in terms of their own benchmarks, they kind of favoring themselves quite highly across all the boards. So just to get a bit of fairer analysis, I'm just going to jump to artificial analysis website. So they just have all of this like stacked up. And here we can actually see they're still rating in terms of intelligence that GPT 5.2 is a lot higher at 51, where Kimi K2.5 is 47. But that's still really good. That's the same level as most of these models, just slightly behind. And remember, this is open source and free. All right, so the other one thing with this I do want to state is this whole idea of calling multiple agents and tools at once. And this is the cool thing I'm actually liking with this model, and I've been experimenting a little bit with open code. And I think this is where a lot of this power comes in. Because this model can reliably delegate things to multiple agents and tools at once and then receive them and process them, this opens up a lot of different avenues into build things. And I always find this kind of interesting that open source models seem to bring these new paradigms to the model market, so to speak. We saw this with DeepSeek, and now we're probably seeing it with Kimi. Not that agent swarms and multi-tools have been not been there before, but we just haven't seen it on the scale before. But anyway, just to go into all of this, they say they can do 1,500 agents and tools at once. You can come read the blog. I'll leave the description down below. But just to show you this in code, I just want to show you like a snippet of just doing multiple agents at once with tests involved. So we can split the task and we just run 4 agents at one time doing different sections and look at the result. Hey guys, just a quick shout out. If you are finding this channel useful and all the information I do provide, please hit that subscribe button down below. It really helps a lot. Anyway, back to the video. All right, so I'm just going to run the Kimi K2. What I'm trying to make it do here is I'm trying to run things parallel. I'm just testing to see how good it actually is. Essentially, what I'm going to do here is I'm just adding a products and review section to this ecom website I made in the previous video. But essentially, all I wanted to do is I wanted to make these components, a database schema with timestamps and API endpoints, review UI components, page integration, and review moderation, and then testing. And I think you can do quite a few of this in parallel. So I'm trying to make all of this in parallel and see if we can use Kimi K2.5's ability to manage multiple agents and tasks at the same time effective. So we're just running through here. It's saying this is the plan it wants to do. And it's identifying group A and group B. And we're going to see if it can actually implement all of these in parallel. So I'm just going to tell it to proceed. And we will see the results. Okay, so the task manager is running through this. It's going to run the context. It's going to build up the tasks. All right, so it's created all the tasks. The validation checks are running to see what the main agent will do. All right, so it's going to now execute batch 1 in parallel to see how this works. So it's got one coder agent here. There's second coder agent doing a task 2. We've got coder agent doing 3. And we've got the coder agent, we've got 5. So task 5, so that's the fourth one. So we can see we've got 4 agents running things in parallel. Let's just jump to 1 and see what's going on. Okay, so we can see it is running through all of this quite quickly. All right, so it has some few issues. It's going to fix the errors. And all components are created. It's complete complete. All right, so that last one is done. So we go back to the parent task. All right, so it's executed that, and now it's going to go on to batch 2. So, okay, so task 04 depended on 1, 2, and 3, but 5 was independent, so 5 could run by itself. All right, we can see now that task 4 is done. Now it has task 6, which is a testing task, so I should delegate it to the testing agent to do that last one. So we're now just going to test each one. All right, so we can see it ran in parallel. All those tasks were done. Hey guys, this is Darren from the future. So like it's not really quite clear what was going on. So what actually happened is we had our request that came in, and then we pretty much told the agent, okay, use task manager to understand how we could split it into different groups. And these groups allow these tasks to be done in parallel. So we knew 1, 2, 3, and 5 could be done in its own parallel section. 4 should be done by itself. And there were some other tasks that were relying on these tasks to be done first before it proceeded. That's what you were seeing just before this. So OpenCode was literally just grabbing these groups and then assigning these groups to their own sub-agents that were running. And when this section did from group 1, then it moved on to group 2 and then did the same for group 2. It made its own Coda agents here. And what was happening in the Coda agents themselves, they were writing the code, but they're also validating. And then once all these were done, any little sub steps that we couldn't do with the Coda agent, the main Coda agent here, OpenCoder, just completed it and finished the task. What was nice is we could just see, because the task manager broke everything up into individual and isolated modular tasks, we could also, with the context files linked in them, we could reliably rely on the Coda agent to actually perform the right task at the right time. And we could just get work done faster. So that was literally what was happening in the previous screen. Anyway, back to the video. The one thing I want to say about the Kimi model, the K2.5 model in particular, is it's actually really, really good. I'm actually finding a lot of good results with it. It feels better than Sonnet 4.5 to me, especially for a lot. It's a little bit faster. So I'm actually really enjoying it quite a bit. And at the moment, if you are using OpenCode, it is free for the end of the week. Otherwise, it is really good in terms of jump into as an alternative like to Claude or even Gemini and ChatGPT Codex models. So I definitely give it a try. Anyway, guys, this was just going to be a short video. I just wanted to jump into what Kimi K2 model was. All right, I did do some research. If you do want to run this model on your local, I've got some bad news. It's huge. So it needs about 600 gigs of just disk space for the main model. And if you want to use the quantized version, which they go to about 1.8, you still need 240 gigabytes just to run it. You don't need 240 gigabytes of RAM. You can use disk space and allocate different RAM, but it's going to be very slow. So sadly, there is no great quantized version that you can run on your local machine. So sorry to break it to you guys if you thought you could use this model locally. So that's why you will only see the cloud versions for it. But in terms of pricing, it is very cheap in terms of the cloud pricing that we're seeing. And if we just go to OpenCode Zen, looking at the Zen pricing for Kimi K2, if we look at it, so this is for input and output. So we can see this is a million tokens each. It's 60 cents per million in, $3 for out. The good thing is if you're doing cache reads, it's only 8 cents. And OpenCode actually does, enable caching from default for this model, which is great. So you can actually pay very, very little to run this in OpenCode compared to other models. So it's a very good alternative. Anyway, guys, thank you so much for watching. This is just a quick video on Kimi K2.5 and a really good new model as an alternative. Thanks so much for watching, guys. Give me your thoughts on how you think about using Kimi K2.5. Are you going to cancel any of your subscriptions and just use this model exclusively? Or do you think the hype is not really worth it and there'll be something better coming along sooner rather than later? All right, guys, so let me know your thoughts on Kimi K2.5. Let me know if you're going to be canceling any subscriptions and just using this exclusively. And also, if you are using in the free week right now, let me know how you're finding it so far. Anyway, guys, thank you so much for watching, and I'll see you in the next video.